welcome back to Dragonfly Engineering. So this week we've got a production job that we're going to do. So I'm going to show you the process of loading the mold, starting up the molding process, and then molding good parts. And the parts that we're going to mold are these black plastic box. So there's a base and a lid, and this is going to be in black ABS plastic. And the customer gave me permission to show this on YouTube, so I can actually show you some of the production work that I do. So anyway, the first step, let me show you up close to the box that we're gonna mold here. Can't really talk about what it's used for or anything like that, but anyway, this is what we're gonna be molding thousands of parts with an aluminum mold set. So back to the point, the first thing that we do in a new production molding job is to unload the previous mold. So this is a steel 12 by 12 inch mold, and it weighs maybe 600 pounds. So the top of the mold, for prepping to remove it, I'm kind of levitating the camera above. You can see how we've got these two eye bolts. I've got that rigging strap because the balance of the mold needs to, you kind of have to find the center of gravity, and that happens to be approximately where this winch hook is. The other important thing about the strap here is that it keeps the two halves of the mold together, because if I hooked onto this hook and then I open the platen up and the mold starts to hang off the winch hook, then the backside of the mold may actually slide off of its bearing rods and fall out down to the floor. So here's this is like a truck bed winch arm system. So normally this black steel structure and the winch would be bolted into the back of a pickup truck, so you can pick things up off the ground and stick it in your truck. But I've rigged it to work on this molding machine. But this winch arm is going to be obsolete once the CNC gantry crane is completed in here, or bridge crane. But for now, I'm stuck with this thing, and it does flex a bit. So I'm going to flex it down, and you can start to hear the motor cinch up. So I got the old socket wrench here, and with confirming that we're actually tied on, I will start to remove these strap clamps. So here's the heel block. This machine is from Germany, so it's all metric. I found it's best to completely remove this hardware. So when the molding platen, or when the molding machine clamp opens, sometimes this hardware can get caught in the clamping slot for the backside of the mold and get bound up, and then then it's seeing like 5 or 6 tons of force pulling on your mold. So it's better just to clear all this stuff out. And in the middle back of the plate is the ejector system, which is another hydraulic cylinder and a structure that basically pushes a plate in the mold forward and ejects the part out. So there's a 1/2 inch 13 nut back in there that I need to loosen. And you have to remember to do that before you open your molding machine. Otherwise, you're going to be using your ejector system to basically pull your mold apart, which isn't good. Okay, so the machine's on, so I go ahead and turn on the pump, and it'll get a little noisy in here. So that sound you hear is the machine wanting to heat up its oil. And it does that in the kind of the caution setup mode, but we can go into manual mode. You got to close the gate before anything will happen. So there you can see we released the clamp pressure and the mold started to swing, so I'm going to lift up a little more on it. Okay. We'll keep opening. Oh, there it really fell out. So I'll lift the mold up a little more until it swings out of there. Definitely got some bounce. There we go. And then we'll open the clamp all the way. And we'll pull the heat isolator out. This guy. Okay, so I like to pull out this push rod for the ejector plate of the mold. This is where we unscrewed that 1/2 13 nut. And now I'm going to make sure that we're basically lined up because now we're going to drop this mold down to the floor using our winch control here. So I usually hold on to the cable here and slowly drop it down. This winch isn't the greatest, so sometimes the cable overlaps in the spool up there. That's that weird popping sound that you heard. All right, so I brought the new aluminum mold and it's hooked up underneath the molding machine, so we're gonna lift it up now. This is smaller and a lot lighter because it's aluminum for one thing. Okay. So this is the alignment ring for this mold, and the nozzle is offset in this mold as well. There's all sorts of adapters. This is also a heat shield. This is a metric alignment ring, which is, I think it's 125 millimeters in diameter. This is a 110 millimeter to 4-inch ring adapter for some molds. And then this is an aluminum ring adapter that I made, which is probably the one that we want. So let's see if that fits in there. And it does fit in there, so that's good. This mold needs to be heated, so we're gonna stick our thermal isolator back in, which is fiberglass material, basically a really thick circuit board. And we'll stick that guy back in, because this mold actually has half 13 threaded holes in it, and we're gonna tighten the mold down with through bolts in the A side of the platen. So we'll string this guy on, like so. And then have it all fall off. Let's try that again. So it's like one of those you need 3 hands situations. But I am going to attempt to do this. I always do it. It's just, it can be a little coarse or a little rough around the edges, the procedure I have. So let me get the air ratchet. I'll be right back. Okay, I'm back with our air ratchet with a 3/8 hex drive in the end, like a 6-inch long one. So what I do is I pre-position the hex drive into this socket cap head half 13 bolt that goes through the platen with one hand on the bolt or the ratchet that's hooked up to this bolt. Make sure it's spinning the right way to tighten, not loosen. There we go. And then I'm going to attempt to string all this together without that alignment ring falling out. And then also keying the alignment ring into the molding machine platen as well. There we go. So, not elegant, but functional. I'm sure I'll come up with a better way, especially when the gantry crane is here, so I can fine tune the position. So I'm gonna tighten the rest of these bolts. So let's go ahead and close this gate, turn on the pump, and then we're gonna move our platen forward and then partially or gently clamp up onto the mold. We're not gonna do the high pressure 30 or 90 ton clamp. It's just gonna approach and then stop before it actually locks up is what it's called. So let's start the motor, pump motor, go to manual mode, and I'm gonna push the mold or the clamp close button on the controller here. And it will come and hit just like that. Now if I held down on the clamp close button longer, it probably would have locked up. And I should be able to move this insulator up a little bit. I got a block of plastic I use to kind of hammer it up because it's probably still like several hundred pounds of force clamping this thing, but not 90 tons of force. So I should still be able to knock it into place. There we go. Try to get it reasonably square. So now we just reverse the process that we just did. Pull our hook and then lift this guy out of here. Okay, now we will, after I double check everything, because it really sucks if you drop your mold. Oh, actually, there is a tie wrap up here that's holding the 2 mold halves together. And a few times in the past when I open the mold up and I forget to pull this nylon strap off, it just breaks like a wet noodle. And then we will slowly open up to make sure nothing bad happens. go. So, the mold open, that's good. Nothing fell off. Now what we're gonna do is I'm going to put the ejector plate push rod back in. Kind of hard to reach back there with this door. So let me move the mold forward a little bit just so I can reach it better. Like to there. When you're messing with ejector plates, you don't want to close the mold because it's real easy to push the ejector plate and ejector pins forward. And you don't want your ejector pins to actually hit the cavity face of your mold itself, because you'll basically scratch or dent in a bunch of little ejector pin marks in the finish of your mold. So always keep a gap when you're messing around with ejector plates and pins. Now I can fit my ejector pin or my ejector plate push rod kind of through this structure and screw it into the mold. Okay, so here we're looking at the front of the mold. So I'm going to slowly inch forward on the ejector plate or the ejector system so that we engage that rod that we just screwed in. So we know we've engaged when we start to see the ejector pins move out the front of the mold here. So I'm just kind of touching it, and there we go. So all of the ejector pins move forward. So now what I'm going to do, turn the pump off. Now we're going to check to make sure that the mold will clamp up. Actually, I'm going to double check the ejector pins. So the pins are back. Now we're going to clamp up. And there we go. That was the high pressure hydraulic clamping up to 90 tons, I think. And then we'll back off. Go to the mold open position, and then we will eject. That's a long eject. Let's reduce the ejection. That's a little better. Okay, so we're using the white and the green temperature controllers on that molding machine over here. So we're going to flip on the output for both of those. And I like to make sure that I actually see the temperature rising to make sure I didn't screw anything up. And we also want to check for smoke. So now what I'm doing is just making sure I don't see any smoke coming out of any of the heaters, to make sure the heaters are seated correctly. And I can feel some heat in the aluminum next to the heater. So that's good. And we shake it. So we brought our plastic stock here into the molding room. Then we've got this siphon hose here with a stainless steel tip, and we basically just put this siphon down inside of the plastic. It'd be normally a lot more plastic. Okay, so here's the automatic plastic feeder. There's a vacuum motor in here, basically just a fancy vacuum sweeper motor. In the back there, which you may or may not be able to see, is the other end of that 2-inch hose, which goes into the bottom of this Venturi sucker. And what we do is, when this orange sensor, which is looking through a glass cylinder, can't see that there's plastic pellets, then it'll turn on the vacuum sweeping motor at the top. So I just flip this thing on and it goes through some procedure. To be honest, I never really read the instructions. I just know you got to hit run set 3 times, and on the 3rd time, oh, there it goes on the 2nd. Let's see here. Let's try again. So on the 2nd time, what it's doing is what it just did there is it sucked pellets out of the container on the floor all the way through that 2-inch hose and filled the hopper up. And so this thing's ready to go as far as feeding plastic to the machine. And then as this hopper depletes of plastic, the sensor will see that there's no more plastic in the tube and turn the vacuum pump on again to add more plastic. I can explain briefly the injection unit. So here is the hot nozzle. And then this is a long barrel with an auger inside, all the way back to the beginning of the barrel where the plastic feeds in. And basically what happens, and there's heat guards, but this whole barrel has got electric heaters, and it basically melts the plastic, and then an auger turns the plastic that starts at pellets and then turns into liquid plastic on the other end, and advances all that plastic forward and then shoots it out the nozzle with like a hydraulic cylinder in their back that kind of turns the auger into a piston, and it just squirts the plastic out the front into the mold. So another thing that we're going to do in this setup, let me get this guy out of the way, is to implement a conveyor belt system to pull the molded parts that come out of the mold. They're going to drop as short of a distance as possible onto a rubber conveyor belt, and then the conveyor belt will bring the parts down out of the way from underneath the molding machine, and then a second conveyor belt will shuttle the parts over to a big bin to collect for trimming later. Unfortunately, this is not automatic for trimming off the gates and the flasher and anything, so it's going to be some manual work. But at least with a conveyor belt system, we can get the parts moving along so they don't just build up in this whole area, you know, and it becomes basically jammed up with parts that this machine makes automatically. So let's go ahead and get the first conveyor belt positioned. I've already brought it into the room, and we got to get it up underneath the molding machine, and it may be a little tricky because I moved this new molding machine in here not too long ago, and I haven't tried to get a conveyor belt under here. So let's see what happens. Hopefully it fits. Stick this thing in. I don't want to do anything. So far so good. Here we go. Okay. Oh, wait, so see that. Okay, not too bad. Oh, zoom in down here. Did you see any parts when free falling? Let's see if I can tip this up. There we go. Ooh, that looks like that's the size of a go. A little bit. A little bigger. Just bigger that. That's usually what you gotta do in small business environments is adapt always. So that's it. There's a move around that. I'll do that off camera. Okay, so for this second, let me get a place in our spot in here. Okay, we are set up to run here. So I put the other conveyor belt in, which is just horizontal, and it pulls the parts out of the back corner underneath this molding machine out to a tub right here. And I'll be continually swapping these tubs out because I need to do the degating and some cleaning up of the parts offline. All right, so moving into the molding area of the molding machine itself, you can see here that I've added this floppy piece of polyethylene plastic, and this will help arrest the part when it falls off of the mold. After it ejects, it'll hit this piece and decelerate it and kind of control its velocity until it actually lands onto the belt underneath. All right, so the oil in the machine is warmed up, the nozzle is heated up, and the plastic is hot. So we should be ready to mold our first part. So now we're looking through the window of the injection unit side, and that's the hot nozzle. And what I'm going to do is purge out the plastic that's in the nozzle ready to shoot into the mold. And again, we're doing this because this plastic sat for a while and while it was heating up, so it may have degraded a little. Or maybe it doesn't have any in it. Oh, there we go. So actually the ram was all the way forward, so now I told it to do an auger fill. So the auger turns and it loads more plastic into the injection unit. But as you can see, my back pressure is such that the plastic just squirts out the end instead of filling the unit, which is good because we can get all that old plastic out of there. So now I'm gonna pull this plastic out, which is hot, so you gotta use a wrench or something, like I'm doing here. And I'll put this in some water. Now in this case where the plastic is so fluid when it's molten that it doesn't really want to fill, I put an aluminum block between the mold and the injection unit, and then you push the injection unit up against the aluminum block. And that basically plugs the end of the injection unit and allows enough back pressure for the auger to fill the injection unit. Or effectively we're preventing the plastic from squirting out the end. So let's close the gate here. So then we're moving forward until we hit that aluminum block that I temporarily put in there. And now when I do an auger fill, which I'm gonna hit the button which rotates the auger inside of the injection unit, we're not going to see all that plastic squirting out the end. And now I can back the carriage up, and now the nozzle is ready to squirt plastic out. And then it's good to pull the drool off the end of the injection unit. I can pull this out of here. Okay, so we've got a full shot of plastic in our hot nozzle. So now we're going to open the mold up. So I'm going to hit the semi-automatic button on the molding machine, which basically means it'll do one full molding cycle and then stop. It won't try to do another one because I'm going to be checking out the part and seeing how things are looking. And then I'm going to hit the cycle start button on the molding machine controller. And there the mold closes. And then the nozzle advances, which is off camera. And then we squirt the plastic into the mold. So there's a plunger on the injection unit that shows the position of the plunger. That sound was the molding machine filling the injection unit with a new shot of plastic while the mold was still closed, so that we don't have that drooling problem that I showed you when we started up. Now the molding machine is letting the plastic cool inside of the mold. And now we open the mold up and we'll see how our part looks. And it ejected. So that's good. So it's always nice that your first part ejects. This is a saved program, so all of this ran before in automatic mode. So I'm not too surprised that the first part ejected, but it's always a nice thing to see. So I'm going to hit the cycle start button again. And we're filling the plastic. The molding machine fills the plastic, but leaves like 3 or 4 millimeters of plastic in the injection unit so that it can transmit pressure into the mold itself. If the molding machine bottomed out onto a hard stop when it's injecting the plastic, then you can't build pressure up inside of the mold. So you always need a little extra plastic left in the injection unit. Here we are opening the mold again. Oh, and then we got tear out there. So I'm going to go to manual mode. So here you can see on this shot that some of the plastic got stuck in the mold itself. So I'm going to turn off the pump so I can reach in there safely, and we'll figure out what's going on here. It could just be that the mold isn't quite set up and ready to run in production yet. A lot of times you gotta run like 12 or 20 parts before you can walk away, and have the machine working continually. So let me clear this chunk of plastic out of the mold and then we'll reset. So yeah, let's just go ahead and see what happens with this next shot. Oh, that sounded a lot better. All right, let's try again. Yeah, no more tear out. So we just had some funky plastic at the beginning of the run, I believe. And then here's our parts coming down the conveyor belt. These are all going to be thrown away until at least like 10 parts in. But yeah, I think we're looking good. Let me make sure our catch bin is good. So this is the runner or the sprue that's still attached. And this is what I'm going to be cleaning off later. Some of them are falling off, but that's okay. I could probably slow this belt down. So we can get a nice line of parts coming. Just barely have it running. Oh, I got to keep on the molding machine too. Maybe I'll zoom back out to everything. Well, I think we're running good here. So I'm gonna go ahead and hit the automatic button and then the start. So now the molding machine will just continually cycle, but it is still sensing to see if there's a part stuck. When the clamp closes, it's sensing the pressure, and if it sees pressure when it's not supposed to see it, then it will open the mold back up again. And it looks like the cycle time is 50 seconds per part. All right, well, here is a partial collection of our first haul of parts. This is about a day's of running. I think it's like 1,200 parts in there. And yeah, so now the hard part is to basically deburr any of the extra flash and degate and package these parts up, which is the bulk of the work. Okay, here's a tighter shot of the mold that we just ran. So this is the A side, the cosmetic side. Oh, excuse the air compressor turned on. And basically this is a bead blasted finish, aluminum machined surface that was then bead blasted with little glass beads. And then over here is the B side of the mold, which is basically the inside inner workings of the part with ejector pins. These are the 4 alignment pins. Now the next mold was even more of a pain because it's a deeper draw, because it's the base part of this box. And I actually had to use compressed air to help eject that part. So we're gonna take a look at that next. And I've got that mold queued up to load into the molding machine. So let's go back in the clean room and load that second mold up. So the next mold that we're gonna do is the base that goes with the lid. We did the lid first because it runs a little quicker and it's just faster to do. And now the base takes a little bit longer and is a little more complicated. Like I mentioned, we have to hook up compressed air to it to aid in the popping or ejecting of the part off of the core of this mold. So without further ado, let's go ahead and pull this mold up into place, and we're basically going to do the same process. I'll probably time lapse all of this because you just saw the process a few minutes ago with the lid mold. Okay, I got you zoomed in looking at the B side of this mold. Now this part that comes off this mold has some holes in the sidewalls. So this is the A side of the mold. And here you can see there's 2 pins. This is a 1/2 inch hardened tool steel dowel pin. And then here's the other dowel pin over here. And you can see how these pins are at a 30-degree angle. And then this plate right next to the pin is called a wear plate or a heel block with a wear plate on it, which is also at 30 degrees. And then if you look back over on our side pole assemblies over here, so looking at our side pole over on the B side of the mold, basically this hole here, which is a 30-degree hole going this direction, lines up with that pin that's also at 30 degrees. And it creates a cam action. So the pin as it's tapered and this hole as it's tapered, as the mold closes, this side pole block will slide in and out. So you can see how in the open position, the block pulls back, and then the features on this block, which are a couple of metal posts, pull away from the plastic part that's stuck on the core of the mold. And then when the mold actually fully clamps up, that heel block and that wear plate that I showed you basically becomes coincident and pushes on this entire angled surface here, which is also 30 degrees. So the high pressure mold clamping action pushes this heel block up against the core of the mold, because there's when we inject plastic, there's like 20,000 psi of plastic, and that creates maybe it's probably like 20 tons of force trying to push this block back. But with the heel block pushing this guy against the mold, it stays put, and thus we get holes in the side of our part, which are created by the pins or the features on this side pole. Let me pull this side pole out. So you can see on this side of the mold, this post right here closes off on the core, which you can see the witness mark of it right there. So the plastic squirts around this feature, and then when it's time to eject the part, this side pole pulls back, and the one on the other side, and then you can eject the part freely, so it's not interlocked into this feature in the mold. So, but one problem with aluminum molds, because this is a prototyping mold, is they wear a lot. So you can see all this nastiness on the bottom. So this mold I loaded from the last run, which was probably 2,000 parts. And what happens is the aluminum wears out. It keeps wearing back and forth, and you wind up making aluminum ink, for lack of a better word. There is some lubrication on here, and there's also some broken down plastic residue from just injection molding ABS plastic. So whenever I load this mold back on, I have to clean off all of this funk, because it'll discolor the molded parts as well. And this is billet machine, so I used like a keyway cutter to machine in the guide rails for this mold. And again, this is an aluminum green mold, so it's not intended to last forever. And eventually this thing will start wearing out, and we'll get more flash and problems just from the mechanical action of this thing sliding in and out. In fact, it doesn't want to slide outside of its normal travel. So if I kick this thing in with my palm, now you can see how it's worn itself in, and it only really wants to travel in that amount of travel. Every time the mold opens, the guide pin on the A side will push in this tapered hole and push this side pole out of the way. And then when the mold closes, the guide pin will get back into this hole and start to bring the side pole back to its final position. Now this part also has trouble ejecting, so I actually have this air port right here, and I actually put compressed air into the ejector system of this mold. So when these ejector pins open, there's actually compressed air that helps pop the part off of the B side of the mold, because it had a lot of trouble ejecting. This is the pressure assist ejection. I don't remember if I hogged out or ground in air lines into the base of these ejector pins, but a common trick is you can use the ejector pin itself as kind of like a pneumatic valve, where when the ejector pin ejects forward, this tip here, the leading edge of the ejector pin, has to remain perfectly round and a tight fit to the mold. but after it leaves the surface of the mold cavity, you can have a ground-in flow channel. Now all these ejector pins do have O-rings in the back, so that compressed air isn't just blowing out the back of the mold all the time. Okay, I think we are ready. We've got a new shot of plastic, mold's hot. Oh, let me turn on the compressed air for the eject assist. All right, hit the semi-automatic button and the cycle start button, and let's hope for the best. Okay, we clamped up. We're gonna watch the plunger position. Yeah, and it looks pretty good. It looks like we got a full shot. There's about 5 millimeters of molten plastic left in the injection unit. So let's see if we eject okay. I gotta load more plastic soon. Okay, so I can see the plastic part is kind of puckered up from the compressed air. And then we eject off. Nice, there you go. And I could see that there was a short shot, which means the mold didn't completely fill, but that's kind of common for first shots. So let's go ahead and keep going. I'm gonna go to automatic mode. Soon I gotta run and get some more plastic. All right, so there we didn't bottom out on the injection. That's good. Here comes the first box. Yeah, it's definitely got a short shot on it. Maybe I'll reach in there and get it. Let's see how our second one comes. Okay, that one looks like it filled out. I'll get you a better angle here in a second. Fall's good. All right, let me grab this off the conveyor belt. Okay, so here is the first part that we molded. Let me get the focus right. So you can see how basically this underfilled, which is pretty common. All right, so I did notice that there's a bow in these parts. Let's see if you can see here. So yeah, the top here, there's basically like a bow shape there. And I recalled after seeing that all of these parts have like a dome top, is that I actually need to turn the compressed air on the ejectors on when the mold is completely open right before it ejects. Because what's happening is with just constant air pressurizing the back of this part, the part kind of swells out or pushes out from compressed air like a balloon while the plastic is still hot. So I've actually had the mold, and again, I molded these last like 2 years ago, but I have the mold opening really slow so that this plastic can solidify better. And then at the end of travel, I've set up a switch and a pneumatic valve at the base of the molding machine to turn on the compressed air just right before the part ejects off. So let me show you my switch setup and my kind of temporary pneumatic valve that's on the floor next to the molding machine. Okay, so I added this electric switch right here. And when I click it, a valve on the floor opens up. So let me click this. You can hear that pop sound. That's a solenoid valve that turns on the air for the ejector. All right, so there's our switch, and I gotta open the mold all the way up so it touches. Let me try again. No, still not quite there. So I'm gonna adjust the mold open position to 368 millimeters. And then we'll go forward, and then we'll try going back again. And we want to hear that air piston pop. There we go. Okay, so now we're air assisting the eject on our ejector system. And then when we go forward, we close the circuit, or open up the air circuit. Okay, here we go. So we'll open the mold up again to full open. We get the air pressure going. Then I'm gonna hit semi-automatic and start. And we're off to the races. The mold clamped up. We're injecting the plastic. Now the auger is filling for the next shot while the mold is still closed. That way it doesn't drool out the front. Injection unit backed off, the mold on the front side. We're sucking more plastic into the injection unit with that vacuum loader. Now the mold is sitting here cooling the part. Now we're going to start opening, and the side poles move open from the cam pins on the A side. And I don't know if you can see it, but we don't have the bulge on the part. And there the air turned on to eject the part. Now I was kind of fussing with getting that switch set up for a little bit, so we've got an undershot again. So let's shoot a few more parts here, and we should start to fill out the mold like before. All right, so I got the mold set to open real slow so that plastic has a chance to solidify. And then at the very end, you're gonna see kind of it bulge out from the compressed air right there. And then the ejector pins help and continue to release the part from the mold. Without that compressed air, I would actually get stress marks in the plastic bottom of these boxes that were shaped like the ejector pins. So there was just a little too much ejection force. So by adding compressed air, you actually create like a compressed plane of force to help eject the plate off of the mold. So you can see what the A side looks like when we open a part. You see how I don't know if you saw it, but the side poles moved out away because of the guide pins, that 1/2-inch angled guide pin. Well, it looks like we got the second mold running pretty good and automatic, so all that's left is about maybe 8 hours and 1,000 more parts, and then a whole lot of clipping and packaging and shipping after that, which, like I mentioned before, is the bulk of the work. Anyway, so thank you for watching the production mold setup show, and I'll see you guys next week. Thanks, bye.